when you're working with quantitative data in one variable, after you've figured out where the center of the distribution is, the next thing you want to look at is how much spread or dispersion or variability is in the data. How spread out is this distribution of numbers? A good measure of spread would have a value of 0 if all the data values were equal, because in that situation there would be no spread and the measure should be equal to 0. And if the data values are more unequal or more spread out, the measure of spread should increase. Here are 4 common measures of spread that all have this characteristic. They're equal to 0 when there's no spread, all the data values are equal, and they increase as the data values become more unequal. The first is the range. The range of a set of values is the difference between the maximum value and the minimum value in the set. It's just max minus min. That's all it is. And that's a number. When you do this subtraction, you'll get a number. It's not an interval. You wouldn't say it's from here to here. You would just say it's this number. It's easy to calculate, but it's calculated from the most extreme values in the data set, and so it's not resistant to extreme values, and that's its major drawback. The IQR, interquartile range of a set of values, is the difference between the third quartile and the first quartile. So again, that's a difference. You take that number and you subtract. Okay, the result is a number. It's not an interval. Okay, now it's fairly easy to calculate, and it's calculated from the quartile, so it is resistant. So the IQR, the interquartile range, has this great feature of resistance that the range lacks. Here's an example of how you calculate both of those. Here's this example that we looked at before. We've got 1, 2, 3, 3, 4, 5, 5, 6, 7, and 9. The maximum value is 9, the minimum value is 1, so the range is going to be 9 minus 1, or 8. Do not say the range is 1 to 9. The range is a number, 8, not an interval. The IQR is Q3 minus Q1. Q3 is 6, Q1 is 3, and the difference is 3, not 3 to 6. Okay? Now you use the IQR as your measure of spread whenever you use the median as your measure of center. These things go together. They are calculated from the same stuff. The median is the median of the whole data set. The IQR is the difference of the medians of the top half and the lower half of the data. So they're from the same family of measures, and they belong together. A third measure of center, or of spread rather, that we're going to look at is the variance. Now the variance is calculated from this formula. It's quite complicated looking. The variance is called S squared. That's how we abbreviate it. And this formula contains a whole bunch of component parts that we'll look at individually. X sub I is an individual data value. Okay, if X is your variable, X sub I would be some value that's in that list of data values. X sub 1 would be the first number that you see, X sub 2 would be the second number that you see, and so on. X bar is the mean of the data set, which we looked at before when we were talking about measures of center, and is the number of data values that we have in our set. Okay, what this formula does, first you have to find the mean, and then you find the difference between each data value and the mean of all the data values. That's what they call a deviation from the mean, right there, X sub I minus X bar. And then you square those deviations. And then once you square them, you're going to add them all up. That's what this letter means, right? This symbol right here means. This Greek letter sigma, it means sum. Okay, this means add up all the squared deviations and then divide by this quantity n minus 1. It's 1 less than the number of data values, or 1 fewer than the number of data values. Now when you look at that, you say, that's going to be some work if I want to use that formula. And it is. We'll do a few examples of that in a little while, but it's quite a bit of work. It's hard to calculate this variance. It's not resistant. It's based on the mean, and some of these X sub i's are going to be extreme values. So they're going to have a big effect on what the value of the variance works out to be. So the variance is not resistant. And the weird thing about it, the really weird thing about it, is that it comes in a unit that's the square of the unit in which the original data are measured. If you measure your data in feet, for instance, okay, these deviations are going to be in feet. When you square them, you're going to get square feet. You're going to add up a whole bunch of square feet. You're going to divide by this number. Your answer is still going to come out in square feet. So that's a little bit strange. If you're trying to describe a distribution where all the values are measured in feet, having a measure of spread that's in terms of square feet is maybe not the most convenient thing to do. But still, it is a very useful concept, the variance. It's very important later on when we talk about random variables. And for now, its main importance is that it is the parent of the standard deviation. Okay, the standard deviation gives an approximation of a typical observation's deviation from the mean of all the data values. So it gives a typical or average deviation from the mean. And that's where it gets its name, standard deviation. What is a typical deviation from the mean in this data set? It's simply the square root of the variance. So once you already have the variance, S is very easy to calculate. But if you're starting from scratch, S is hard to calculate. Like the variance, it is not resistant. But it does come in a unit that is the same as the unit of the original data. So it makes sense to describe a distribution with S because if you're talking about data, you want your measure of spread to be in the same unit as your original data are. Okay, now S is never a negative number. Okay, it would be equal to 0 only if all the data values are equal and therefore all equal to X bar. And that means all the deviations from the mean would be 0. You square 0, you get 0. You add up a whole bunch of zeros, you get 0. And if you divide by n minus 1, you still get 0. So S is going to be 0 only if all the data values are equal and therefore equal to X bar. Otherwise, S is going to be a positive number. It's a positive square root. And the more the data are spread out from X bar, the larger S is going to be. Now, S should be used as the measure of spread whenever the mean is the measure of center. So this is another family of measures. The mean and the standard deviation go together as a pair, just as the median and the IQR go together as a pair. You don't want to mix and match. Don't use the IQR as your measure of spread when you use the mean as your measure of center. And don't use the standard deviation as your measure of spread when you use the median as your measure of center. Okay, those two different families of measures, they need to be kept separate. They do complement each other, but you want to keep them separate when you're talking about center and spread. Use one group or the other.